remember when I showed you that table with all the elements that the plant needs for growth? Well, today we're going to look at how to obtain those elements and in what quantities for our plants maximize its health and potential. Now, if you remember, the carbon, hydrogen, and oxygen that we need for plant growth are available from carbon dioxide in the air and from water from the soil. So as long as we have, sun to pump that photosynthesis process and take the carbon dioxide, and we have enough moisture in the soil, we're going to be able to obtain sufficient quantities of those three elements. However, there are another group of those elements that are needed in fairly large quantities: nitrogen, phosphorus, potassium, calcium, and magnesium. And the soil that we have may not naturally be able to supply all of those. So, how do we handle that? For instance, a crop of cabbage on a hectare, that's about maybe 25 tons of cabbage, is going to take up 140 kilograms of nitrogen, 34 kilograms of phosphorus, 146 kilograms of potassium, 30 kilograms of calcium, and 11 kilograms of magnesium, according to the New England Vegetable Management Guide. So, at first, on a hectare size, you might think, well, that's not that much. I mean, a bag or two of fertilizer or whatever. But if you think about it, year after year after year, if you're taking those crops off, selling them to the supermarket or wherever, and not replacing the nutrients that you've taken off in the form of the crop, you can slowly start to deplete the soil. So it's helpful for us to think about what we're removing and maybe what we can put back into the soil to keep our farming sustainable. Anytime you're starting to work on a new piece of ground and you don't know about its fertility or crop history, you want to take a soil test. Now, you might not be able to find a really great laboratory to analyze your soil right near you, but there should be at least one within country. So try to check it out. If you can't, sometimes I will just order a soil test kit online and do it yourself at home. So basically, a soil test is taking a sample of the soil at the depth at which most of the roots are, the tillage is. So usually it's 20, maybe 30 centimeters deep. Yeah. So we're going to take our soil sample from the depth to which we have tilled. And that is typically also where most of the plant roots are. So the first 15 to 20 centimeters, we combine the number of samples that we've taken in the field, and we send a small subset of that to the laboratory. Now, you can find a video on how to do this on the internet. There are plenty of them. But when you get your sample ready and send it off, I would recommend getting it tested for soil pH, percent organic matter, phosphorus, potassium, and then if you can, for sulfur, maybe calcium and magnesium. And if you're really type A, you can test for some of the soil microelements, namely iron, manganese, copper, zinc. You can also find out a lot about the soil just by talking to your neighbors, people that have worked in the area, that have worked with the soil, and you can find soil maps, usually on the internet or the local government offices, because most of the soils that we work with in the world have been already tested or named, and some of those characteristics will help you to understand how to better work with your soil. So, we got the results of our soil test back, and it's saying that the pH of our soil is 6, The percent organic matter is around 3%, and we have low amounts of phosphorus and potassium, but adequate or medium levels of sulfur, calcium, and magnesium. So, as it pertains to the cabbage crop, pH of 6 is fairly low. We would actually like to see a pH of 6.5, maybe up even to 7.5. So we will need to apply some lime, some calcium carbonate. So that should be applied well before you plant the crop, so that the calcium carbonate has time to break down and start the chemical process that will raise that pH. You'll find a link on how to do the calculations for the amount of lime you'll need down below in the notes. You might wonder why I didn't mention anything about nitrogen. Well, if you think back to the two forms of nitrogen that the plant can absorb, remember that the anion, that nitrate, the negative charged one, doesn't have as many sites on the soil or organic matter to bind to, and often is floating around and can be lost when the rainwater leaches down through the soil profile. Well, we also have ammonium, and that can volatilize, becoming a gas, NH3 instead of NH4+. That actually can float away up through the soil and be lost as well. So when we are applying nitrogen, we'll actually try to put it on almost when the crop needs it, so not very far ahead. And so testing for soil nitrogen, because these forms change and move, can be very difficult to quantify. So we pretty much just apply the amount of nitrogen that we know that the crop will need. Back to our cabbage crop. Remember that we said we needed 150 kilograms of nitrogen, 50 kilograms of phosphorus, and 150 kilograms of potassium in order for our crop to be growing well and to not deplete our soils. So there are pretty much two ways in which we can supply those nutrients to the crop. One would be through synthetic fertilizer that we put on with the crop, and the other would be through manure. Now, manure is great because it contains organic matter, which we know helps the soil to stick together as it's being decomposed. It holds water and feeds the soil microorganisms. But sometimes the ratio of the nutrients in the manure is not ideal for what we need for the crop. Let's say you have a nice pile of cow manure that your neighbor will give, well, maybe sell to you, right? An estimated amount of nitrogen, phosphorus, and potassium in that manure would be 4 kilograms of nitrogen, 1.5 kilograms of phosphorus, and 1.5 kilograms of potassium per ton. I will also include a link to the manure analysis down below. Now that's an estimate, and it'd be best if you could actually test the manure, but I know that's not always possible. Anyway, if you have 40 tons of this cow manure per hectare, that is going to be like applying 160 kilos of nitrogen, 60 kilos of phosphorus, and 60 kilograms of potassium. And most of the time, when applying manure, we will figure that after volatilization, that is that ammonium changing to ammonia and leaving as a gas, and leaching of the nitrate by rainfall, the plant will only be able to capture around 30% of the nitrogen. So we are left with 53 kilograms of nitrogen, 60 kilograms of phosphorus, and 60 kilograms of potassium. So enough phosphorus, but we're low in the nitrogen and the potassium categories. What do? We go looking for fertilizer that will help us to make up the difference. Here is a table of the major types of fertilizers and the amount of nitrogen, phosphorus, and potassium that they contain, along with some of the specific other nutrients. And these are on percentage basis by weight, so kilograms per 100 kilograms of fertilizer. Since for our cabbage crop we're going to need another 100 kilograms of nitrogen and 90 kilograms of potassium, we might consider a nitrogen source such as ammonium nitrate, which is like 34% nitrogen, and then either potassium sulfate or potassium chloride. Potassium chloride actually breaks down much more quickly than sulfate of potassium. But then sulfur is usually needed in larger quantities in cabbage than chloride, which is a microelement. Fertilizers can have characteristics like salt that draw moisture out of the plant. So when we look at potassium chloride versus potassium sulfate, potassium chloride is much saltier than potassium sulfate. And so if we would put it on the crop, we would make sure that we wouldn't put too much or too close, that it would actually hurt the crop. Since ammonium nitrate is only 34% nitrogen, we're actually going to have to apply 300 kilograms of ammonium nitrate in order to get our 100 kilograms of nitrogen. And for the potassium sulfate, that's only 50% potassium, so we would have to apply 200 kilograms of potassium sulfate. Potassium chloride is 60%, so we could probably get away with 150 kilograms. Make sure to do these calculations and not just assume that a potassium fertilizer is 100% potassium, or vice versa, nitrogen fertilizer. But synthetic fertilizers have a specific composition, they're easy to handle, and they can be applied during the growing season for things like vegetable crops. You see, manure has bacteria in it like E. coli and listeria, at least sometimes, and that can be transferred onto the growing crop and then cause food poisoning for the consumer. So for things like vegetables, anything that's eaten fresh, manure should be applied at least 90 days before planting that crop in the field. And that allows time for the bacteria in that manure to die off, to freeze out, to be decomposed, so that when the crop is growing, it can remain safe, clean, and you don't have any qualms about what's on your plate. So, although we like manure, it's great stuff for the soil, we need to think about how to use it correctly, and that's why synthetic fertilizers are sometimes a nice thing to have. I know that this explanation of soil fertility, manures, using fertilizers is really just skimming the surface, like no pun intended. But the point is that if you take time to learn about each of these inputs, how and when to use them, your soil will thank you. Your crops will produce better. You will make money, at least more money than if you hadn't thought about it. So take time to learn, to figure out how to implement what you're learning into your practices, and you'll be a better farmer.